Okay, we're doing the last section of Lab 7. We're on the last page. We're going down to step E. We have an extra layer of dielectric now. And the reason for that is we're going to start rolling and folding the capacitor, and we need to make sure the two plates don't short each other. So we have this extra piece of dielectric. We're going to lay that right on top, just like that. And now we're going to roll it up. And to help with that, we have just a steel rod that we're going to just temporarily use just as a template for rolling. So I'm going to carefully roll this. I'm going to try to get all the layers here and try to keep everything nice and square. And once it's started, it goes a little easier. And hopefully I didn't do it so tight that I can't get it off of the rod. Okay, we got success. At least I think it's successful. We're going to find out. We're going to see what kind of capacitance we get. Okay. Try that. Ah, look at that. We hit our goal. Right on the money. That's good. Now, just for curiosity, so that's part E. We're going to move now on to the last step where we keep it rolled, we're going to flatten it, and we're going to compress it again. Let's see if we can even get a little bit higher than 20 nanofarads. Okay, so I have that flattened. I think I'm going to make sure I can still access the tabs of the capacitor, but let's try that out. Let's see what happens. Look at that. We got almost 3 times the expected capacitance, and that's actually normal. One of your questions there is to try to figure out why. That's actually your last question. We didn't exceed that goal. We got 3 times the goal. See if you can think about why that could happen. Think about what happens to the capacitor when we roll it up. It's a pretty tricky question, but give it a try and see what you can come up with. Why would this new capacitor being rolled and flattened, how could that possibly give us such a large capacitance?